Hello friends, I am Balaji Rao. Welcome to BR Max class. In this class, we are going to learn chain rule differentiation. For a human being, heart is how much important? Like that, for differentiation chapter, chain rule differentiation is that much important. We use this chain rule differentiation very frequently while doing differentiation. To learn this chain rule differentiation, you need to know two things. First one, you need to learn all 23 formulas that what we learn in first class of differentiation chapter. Second thing, you need to know basic differentiation. You need to know how to use basic rules of differentiation that what we learn in second class and third class. Actually, chain rule differentiation is differentiation of composite function. I don't want to make the things are complicated. In this class, I am going to tell you the trick in what way we can do chain rule differentiation very easily. So, this is fourth class in differentiation chapter. We are learning about chain rule differentiation. I'll do this chain rule differentiation in two videos. This is first video on chain rule differentiation. Without much delay, let's begin the class. You see this first question, derivative of 2x plus 3 whole power 4. We need to differentiate this. How to differentiate this? You learn 23 formulas. Na? In those 23 formulas, which formula is suitable here? You know this formula. Derivative of x power n is n into x power n minus 1. In general, how we use this formula? Derivative of x power 4 is there. By using this formula, this can be written as 4 into x cube. Right? When it comes to this problem, how we use this formula, that is important. What I'll do, I'll imagine this 2x plus 3 as x. Listen this carefully. If you understand first three problems, then you can do remaining all problems your own. Try to understand. You imagine this 2x plus 3 as x. Then how it looks? It looks like x power 4. It looks like x power 4, right? What is derivative of x power 4? It is 4 into x cube. So here 4 into, don't write x. Which one you imagined as x? That you write. 4 into 2x plus 3 whole cube into, which one you imagined as x? You need to differentiate it. That is d by dx of 2x plus 3. I hope you are understanding. Simple thing. By seeing the question, you need to get an idea that you need to imagine this 2x plus 3 as x. When you imagine this 2x plus 3 as x, it looks like x power 4. So derivative of x power 4 is 4x cube into which one you imagined as x, you need to differentiate it. I hope you understand this step. Rest of all simple only. See further how we do this problem. 4 into 2x plus 3 whole cube into derivative of 2x plus 3. How we differentiate? We differentiate each and every term because we know the basic rule of differentiation d by dx of u plus v is derivative of u plus derivative of v. So what I'll do here, this I'll write it as derivative of 2x plus derivative of 3. That equal to 4 into 2x plus 3 whole cube into derivative of 2x. Here you know the formula, derivative of ku is k into derivative of u, basic rule of differentiation that we learn in second class. So here derivative of 2x is 2 into derivative of x. What is derivative of x? In last class also I said, I am going to use this very frequently. Every time I don't use derivative of x power n formula. Derivative of x is 1. You better memorize this. Derivative of x is 1. Here derivative of 2x. 2 is constant, take it outside, and derivative of x is 1. Plus derivative of 3. As 3 is constant, derivative of constant is 0 na? So derivative of 3 is 0. If I simplify this inside the bracket, it will be 2. Here 4 is there na? 4 2s are 8. 8 into 2x plus 3 whole cube. I hope you understand this. Have patience. Try to understand first three problems. Fourth problem onwards, you can do these problems your own. You see this question number 2, d by dx of 1 divided by ax plus b whole power 4. We need to differentiate this. To differentiate this, we learn 23 formulas. Na? In those 23 formulas, This looks like which formula? See, we learned this formula. Look here. Derivative of 1 by x power n is minus n divided by x power n plus 1. Here, which one you need to imagine as x? You look this part. Ax plus b. You imagine this ax plus b as x. Imagine. Then it looks like 1 by x power 4. 1 by x power 4. If I apply this formula to this, 1 by x power 4 is what? 1 by x power 4 is minus 4 divided by x power 5. So here, when I apply that formula to this, minus 4 divided by, in place of x, you will write this ax plus b, minus 4 divided by ax plus b whole power 4 plus 1, that is 5, into which one you imagined as x, you need to differentiate it. D by dx of ax plus b. I hope you are understanding. So further, if I simplify this, minus 4 divided by ax plus b whole power 5 into, we need to differentiate this part. How we differentiate? We differentiate each and every term because we know derivative of u plus v, derivative of u plus derivative of v. So I'll write this as derivative of ax plus derivative of b. Okay, further we'll simplify. This part is as it is, minus 4 divided by ax plus b whole power 5 into derivative of ax. As we learn basic differentiation, I'll take a outside, I'll differentiate x. Derivative of ku formula I'm applying here. You take a outside. Derivative of x is 1. See how frequently we are using this formula. Derivative of x is 1 plus. Here b is constant. Derivative of constant is 0. So derivative of b is 0. If I simplify this further, in these brackets you will get a. Here minus 4 is there. Minus 4 into a is minus 4a divided by ax plus b whole power 5. I hope you are understanding. Now we'll move to next question. You see this third question. D by dx of 2 power sin x. How to differentiate this? You learn 23 formulas, na? In those 23 formulas, this one looks like which formula? See here, we know this formula. D by dx of a power x is a power x into log a base e. Here, in this formula, a is constant, x is variable. So, here, you observe this one. This looks like a power x only, na? So, what I'll do to differentiate this, I'll imagine this sin x as x. You imagine this sin x as x. Then it looks like 2 power x. Then you just apply this formula. Derivative of 2 power x is what? 2 power x into log 2 base c. Here 2 power sin x because you imagine this as x. Derivative of this is 2 power sin x into log 2 base c into which one you imagined as x, you need to differentiate it. D by dx of sin x. I hope you are understanding. So 2 power sin x into log 2 base c into derivative of sin x. We learned 23 formulas, na? This is one of those direct formula. Derivative of sin x is cos x. Over. This differentiation is over. If you want, this can be written like this also. 2 power sin x into cos x into log 2 base e. D by dx of e power x square. We need to differentiate e power x square. You learned 23 formulas, na? In those 23 formulas, this looks like which formula? Yes, you see here, we know this formula. Derivative of e power x is e power x. Now you observe, in this problem, if you imagine x square as x, you just imagine, if you imagine x square as x, this looks like e power x. What is derivative of e power x? E power x only. That only I written here. You please observe. That only I written here. You please observe. Now what to do further? Into which one you imagined as x, you need to differentiate. You imagined this x square as x, na? You need to differentiate it. D by dx of x square. Further, if I simplify this, e power x square is as it is into derivative of x square. You know derivative of x power n formula. Derivative of x power n is n into x power n minus 1. Derivative of x square is 2 into x power 2 minus 1. Simply, derivative of x square is 2x. This we learn in basic differentiation, right? So, derivative of x square is 2x. Further, this can be written as 2x into e power x square. You see this question number 5. Derivative of logarithm of tan x base c. How to differentiate this? You learn 23 formulas, na? Which formula is suitable for this? You learn this formula. derivative of log x base c is 1 by x. So what I'll do here, I'll imagine tan x as x. If you imagine tan x as x, it looks like log x base c. What is derivative of log x base c? Derivative of log x base c is 1 by x. Derivative of logarithm of tan x base c is 1 by tan x into which one you imagine as x. You need to differentiate it into d by dx of tan x. That equal to 1 by tan x into derivative of tan x. You learn 23 formulas. Na? In those 23 formulas, this is one of the direct formula. We know that derivative of tan x is secant square x. So 1 by tan x into secant square x. If you want, you can simplify this further. We know from trigonometry formulas, 1 by tan x can be written as cot x. Cot x into secant square x. From trigonometry only, we know that cot x can be written as cos x by sin x. Look here, cot x can be written as cos x by sin x. And secant square x can be written as 1 by cos square x. All these things we learn in trigonometry formulas. I did a video on how to memorize trigonometry formulas. You can please find that video in our channel, or else I'll give that link in cards or in description. So if I simplify this further, this cos x will get cancelled. What is remaining? 1 by sin x into 1 by cos x, which is nothing but 1 divided by sin x into cos x. I hope you are understanding. Now we will move to question number 6. Derivative of sin of e power x. You learn 23 formulas. Na? In those 23 formulas, which formula is suitable here? You see, you learn derivative of sin x is cos x. Right? You know that derivative of sin x is cos x. What I'll do here, you need to differentiate derivative of sin of e power x. What I'll do, I'll imagine this e power x as x. Then it looks like sin x. What is derivative of sin x as per this formula? Derivative of sin x is cos x. That means cos of e power x into which one you imagined as x, you need to differentiate it. D by dx of e power x. I hope you are understanding. If I simplify this further, what you will get? Cos of e power x into derivative of e power x. We know this formula, easiest formula. Derivative of e power x is e power x only. You can stop this problem here, or if you want to write one more step, you can write like this. E power x into cos of e power x. D by dx of cos of root x. How to differentiate? You learn 23 formulas. Na? Which formula is suitable here? You look here. Derivative of cos x. Derivative of cos x is minus sin x. This formula you learn. Now you observe here. I'll imagine root x as x. You imagine root x as x. It looks like cos x. It looks like cos x. Derivative of cos x is what? Minus sin x. Minus sin. You don't write x. You just write root x. Into which one you imagined as x, you need to differentiate it. D by dx of root x. I hope you are understanding. So if I simplify this further, minus sin x into derivative of root x. You look here, I simplified. Derivative of root x. This root can be written as whole power 1 by 2. Root x can be written as x power 1 by 2. Now it looks like x power n. Derivative of x power n formula is what? N into x power n minus 1. So 1 by 2 into x power 1 by 2 minus 1. 1 by 2 minus 1 is minus 1 by 2. So 1 by 2 into x power minus 1 by 2 can be written as 1 divided by x power 1 by 2. You know that a power minus m can be written as 1 divided by a power m. Okay. So here 1 by 2 into, in the denominator x power 1 by 2 is there, na? That we can write it as root x. So 1 divided by 2 into root x. I hope you are understanding. So derivative of root x is what? 1 divided by 2 root x. So derivative of cos root x is minus sin root x into 1 divided by 2 root x. Little bit of practice is needed. All these things are very easy. Now you see this question number 8. Derivative of tan of sin x. How to differentiate this? We learned 23 formulas. Na? Which formula is suitable here? You see. We know that derivative of tan x is secant square x. Then what you will do? In this problem, you imagine this sin x as x. If you imagine this sin x as x, it looks like tan x. Derivative of tan x. Derivative of tan x is secant square x. But in place of x, we will write sin x. I hope you are understanding. Into which one you imagined as x, you need to differentiate it into d by dx of sin x. If I simplify this further, what I'll get? Secant square sin x into derivative of sin x is cos x. That's it. It is very simple. Now we'll move to next question. D by dx of secant of 2x. You learned 23 formulas now. Which formula is suitable here? You see, derivative of secant x. Derivative of secant x is what? Secant x into tan x. Correct? So what you will do here, you imagine this 2x as x. If you imagine this 2x as x, how it looks? It looks like secant x. Right? So derivative of secant x is what? Secant x into tan x. So what you will write? Derivative of secant 2x is secant 2x into tan 2x into which one you imagined as x, you need to differentiate. That is d by dx of 2x. I hope you are understanding. So secant 2x into tan 2x into derivative of 2x. You know basic differentiation, d by dx of ku, k into derivative of u. So what I'll do here, I'll take 2 outside, I'll differentiate x. 2 into derivative of x is 1. 2 into 1 is 2 only. So further, if you want to write this, you can write like this. 2 into secant 2x into tan 2x. That's it. How simple this chain rule differentiation is. Now we'll move to next question. Derivative of sine inverse of e power x. You learned 23 formulas now. Which formula is suitable here? You see, you learned this formula. Derivative of sine inverse x is 1 divided by root over 1 minus x square. So here what I'll do, I'll imagine e power x as x. Then it looks like sine inverse x. What is the derivative of sine inverse x? 1 divided by root over 1 minus x square. You look here what I written. 1 divided by root over 1 minus x square. But in place of x, which one you imagined as x, that expression you need to write. So I written e power x here. I hope you are understanding. 1 divided by square root of 1 minus e power x whole square. After this step, which one you imagined as x, you need to differentiate it. You imagine e power x as x. So you need to differentiate this. Therefore, d by dx of e power x. If I simplify this further, 1 divided by square root of 1 minus e power x whole square. This is like a power m whole power n. A power m whole power n is a power mn. So e power x whole square is e power 2x into d by derivative of e power x is what? We know this formula, direct formula. Derivative of e power x is e power x only. If you want to simplify further, you can write like this. 1 into e power x is e power x divided by square root of 1 minus e power 2x. I hope you are understanding these problems. Now you see this question number 11. Derivative of tan inverse of x square. You learned 23 formulas now. Which formula is suitable here? You see, derivative of tan inverse of x. Derivative of tan inverse x is 1 divided by 1 plus x square. Right? So what I'll do here, I'll imagine this x square as x. You imagine this x square as x. It looks like tan inverse of x. Try to understand. This looks like tan inverse of x. Derivative of tan inverse x is what? 1 divided by 1 plus x square. So here derivative of tan inverse of x square is what? 1 divided by 1 plus x square whole square. After that, into which one you imagined as x, you need to differentiate. That means d by dx of x square. If I simplify this further, 1 divided by 1 plus x square whole square is x power 4 into derivative of x square. We know derivative of x power n formula, n into x power n minus 1. From that, derivative of x square is 2x. If I simplify this further, 1 into 2x is 2x divided by 1 plus x power 4. You see this question number 12. In this problem, I am going to use basic rules of differentiation. You see, this looks like derivative of ku. Basic rule of differentiation. Derivative of ku is what? You look this formula. Derivative of ku is what? K into derivative of u. So this can be written as 2 into derivative of e power sin x. Okay. Now 2 into derivative of e power sin x. We do not have any direct formula for this. Here, which formula is suitable? Derivative of e power x equal to e power x. that formula is suitable. Here what I'll do, I'll imagine this sin x as x. If I imagine this sin x as x, it looks like e power x. So derivative of e power x is what? E power x into which one you imagined as x, you need to differentiate it. That means d by dx of sin x. That equal to 2 into e power sin x into derivative of sin x is cos x. That's it. It is very easy. Now we will move to next question. See this problem. D by dx of cos of log x plus e power x. How to differentiate? Here which formula is suitable? You see this log x plus e power x. I'll imagine this as x. If I imagine this as x, it looks like cos x. We know the formula. Derivative of cos x is what? Minus sin x. So minus sin log x plus e power x into which one you imagined as x, you need to differentiate it. You imagine this log x plus e power x as x na. So d by dx of log x plus e power x. I hope you are understanding. Further, if I simplify, this part will be as it is, minus sin into log x plus e power x into, how to differentiate this? We differentiate each and every term. We know derivative of u plus v formula, derivative of u plus derivative of v. So derivative of log x plus derivative of e power x. Now further, if I simplify this, this is as it is, minus sin into log x plus e power x into derivative of log x. We learned 23 formulas. Na? Direct formula is there. Derivative of log x is 1 by x plus derivative of e power x. Derivative of e power x is e power x only. This is also direct formula. That's it. Now we'll do last problem in this chain rule differentiation. You see this 14th problem. Derivative of sine of x square plus 5. Which formula is suitable here? You answer yes. Derivative of sine x. Derivative of sine x is what? Cos x. So what I'll do, I'll imagine this x square plus 5 as x. If you imagine this x square plus 5 as x, it looks like sin x. Derivative of sin x is what? Cos x. In place of x, we'll write this x square plus 5 only into which one you imagined as x, you need to differentiate it. That is d by dx of x square plus 5. Further, if I simplify this, cos of x square plus 5 into derivative of x square plus 5. We'll differentiate each and every term. Derivative of x square plus derivative of 5. So that equal to cos of x square plus 5 into derivative of x square. You know derivative of x power n formula, n into x power n minus 1. You apply that formula here. Derivative of x square is 2x plus derivative of 5. As 5 is constant, derivative of constant is 0. So 2x plus 0 is 2x only. You can write like this, 2x into cos of x square plus 5. That's it. Dear friends, chain rule differentiation is very easy differentiation. Only the thing is, you need to practice first 4 problems. 5th problem onwards, you will get an idea how to do these problems. Dear friends, doing these videos is not an easy job. I am spending so much of time to create these videos. If you drop a like, I'll feel very happy. If you really like this video, please drop a like and share this video with your friends so that they can get benefit from these classes. If you are not yet subscribed to my channel, subscribe now. Thanks for watching this video. Have a great day. Bye bye.